Okay.
This meeting is being recorded.
Okay, welcome to our now official start of our CS 181 course. Today, first quick reminder here that your, I guess, 2 homework assignments going on right now. The first one is completing up the measuring of the evaluation of your RAG model, which is due this Friday. If for whatever reason you would like to have an extension on that, then let me know. Especially since the office hours were both on Tuesday and last week weird, I'm happy to grant extensions on that. But I also think it's reasonable to get it completed by Friday. Also this weekend, before our next class, the actual new homework assignment for this week is reading this paper right here, The Pitfalls of Next Token Prediction. And again, there's not going to be anything graded with this assignment. And so I also was a student once and realized that it is very tempting when there's something that is not graded to choose not to do it. I recommend, though, that you do actually spend a decent amount of time trying to read this. But I think one of the main ways to benefit from this course, like going forward, say 5 years from now, you are all graduated in the middle of your illustrious careers. The thing that you will most be able to take away from this course is not like, oh, what was the Grok API, or what was the like concrete way to do RAG in this situation. The best long-term thing to take away from this course is how to understand what's going on in the research field, and you won't get a good understanding of that if you're not actively participating in reading some of these articles and wrestling with these concepts yourself. So I think the actual contents of this article you will all find to be interesting, but really the point of this, and we'll read a couple of other papers in class as well, the main point of this is to get you the practice of understanding research on your own, so that after graduating, when I'm not around, other people aren't around, you can understand what's going on by yourself. Again, while reading this paper, the tempting thing, if it's the first paper that you've ever read, first researchy, technical thing that you've ever read, that's not like a textbook, the tempting thing to do is just to start at the top and read to the bottom. But you don't want to do that. You want to focus on the important things. So the abstract, the figures, and spend, when I am reading a paper like this, I spend probably at least 70–80% of my time just understanding what those figures are and why they created them that way. If you can understand the figures, especially in a machine learning paper, then you've basically understood everything that there is to know. Okay, last time we talked about a bunch of training stuff, and I don't know, in my opinion, training is important to know about a little bit, but it's not the most important thing. I think it's relatively uninteresting to us because training requires a lot of money, and in particular, if you don't have a $1 million per year budget, then there's basically nothing that you can do that is a novel contribution, a new interesting thing to do with training. And in contrast to that, though, the inference, so actually using the models, that's sometimes called inference or decoding or sampling, there is a lot of interesting things that go on here that allow you to change the behavior of models to be more like what you want. And these are things that don't require large budgets to do. They are relatively simple, relatively straightforward. You can do them on your own laptop without spending a lot of money. So we'll spend more time here on these inference algorithms today and going forward in the rest of the course. Any questions at a high level before we sort of get started in earnest? Okay. Oh, maybe too, I did post an issue sort of last night that I'm going to do stuff today that needs an OpenAI key. If you want to follow along, then you're welcome to do that with your OpenAI key. You don't have to follow along, though. So that'll be the last half hour, 45 minutes-ish of class. And So you don't need the OpenAI key, but if you have that available, then you'll be able to follow along and do some cool, interesting stuff that can potentially help you out with your RAG evaluations and getting those RAG performance better. Okay, high level, quick overview of sampling algorithms. They're sort of divided into three categories for large language model sampling in particular. There's greedy search, top sampling, and beam search. And this one picture gives you like the overview that like greedy search is the stupid thing to do. These other two things are the better things to do, the things that are generally what you want to do. Greedy search is sort of the most obvious thing to do. It's sort of the standard thing when people are first explaining how a large language model works. This is how we explain what's going on. And if you have some sort of sentence like this, the best thing about AI is its ability to, and then a bunch of what the model does is it creates a distribution over what the next possible word is going to be. And in greedy search, we always just take the most likely word. And in this case, that's learn. It has a 4.5% probability. And we put that there, add it to our sentence, and keep predicting one token at a time. So greedy search, relatively straightforward. Top sampling, also relatively straightforward. The only difference between the sampling and the greedy search approach is that instead of taking exactly the top probability right here, instead of guaranteeing that we take the word learn right here with 4.5%, we just randomly sample from the probability distribution of next words. So 4.5% of the time, the next word here will be learn, 3.5% of the time it will be predict, and so on. We talked a little bit about there's this idea of temperature, and temperature, I'm not going to write out the full equation here of what's going on, but temperature adds randomness into this prediction, that if your temperature is exactly equal to 1, then you're sampling from this exact normal probability distribution. If your temperature is set equal to 0, then these probabilities are changed in a way where this 4.5 ends up becoming 100% and everything else becomes 0. And if your temperature is greater than 1, then these smaller probabilities will get a boost up. So if your temperature is bigger than 1, then the word understand right here will be more likely to happen, and the word learn will be less likely to happen. Some of the intuition about temperature with sampling that you'll see people talk about is that higher sampling results somehow in more creativity, more possibilities to do interesting things, and lower temperature results in less creativity, more forcing the model to do one specific behavior. We talked a little bit about when we were doing the engineering stuff on making doc tests for systems. You can set the seed sometimes to encourage the model to behave a certain way, be deterministic. Another way of encouraging that deterministic behavior is setting the temperature here to 0. Not really needed adjusting this temperature in state-of-the-art models. When these language models first being developed 10 years ago, they were very sensitive to these temperature values. These days, I can't tell a difference between any sort of moderately reasonable temperature value. A 0 and a 1, sometimes I can tell a difference. A 1 in a 10,000, I can tell a difference, but anything moderately reasonable, these are often common choices right here. I can't really tell a difference. It's a high-level, quick overview, review of what we did last time. Any questions on any of that? Ron?
Is the change in temperatures models are harder now and have access to more stuff, or is it because they've changed how the temperature?
Yeah, it's a good question about why state-of-the-art models are less sensitive to temperature. The answer is that the distribution up here is better in state-of-the-art models. Temperature is used exact same way, but the probability in say GPT-4 of if it says the next word is learn, the next word really probably should be learn. Whereas with GPT-1, if it said the next word was learn, then I mean, maybe it was right, but a lot more I guess wiggle room about things. Another sort of intuition about why the state-of-the-art models are less sensitive to temperature is that state-of-the-art models are better. If somehow we made a mistake here, we really wanted AI to talk about whether AI can understand things or not. Is it just a stochastic parrot or not? And so like the answer to that should probably use this word understand. If in state-of-the-art models, if we accidentally sample the wrong word, so like we sample the word do down here or the learn or predict, something like that, state-of-the-art models are like better at somehow coming around and fixing previous mistakes, not by changing the past, but by adjusting what they do in the future to adapt to that mistake. Oops, I accidentally pressed a button. Yeah, I haven't found in any application I've tried that these days adjusting the temperature is worthwhile. But you will see people talk about the temperature a lot on blog posts and things because it used to be very important. Good question. Okay. There's a handful of variations on this top sampling procedure. I think they're mostly sort of like intuitive things that you might think to do on yourself if you sat down and thought about this for a while. This first one is top K sampling. This has been around for forever. And the idea in top K sampling is that instead of considering the entire probability distribution here, we're only going to consider the top K words. So if K equals 3, then we'll only consider these words learn, predict, and make when we do our next prediction right here. And we won't consider any of the words below that. The intuition behind why that might be good is because the models are probably better at, like there's a lot of words in a lot of tokens that are appearing on the internet, on the order of like 50,000 different tokens that most of these models have. And the probability distribution, like the quality of it, is concentrated up at the top range usually. This is something not super popular these days. You'll still see people talk about it. It's available on all the APIs, but by default, it's turned off and not used. If you were using it, common values, 10, 100, 1000 to get just like the very top most interesting things. Not something that I've ever felt a need to play around with to get good results. This top P is something that has replaced top K because it's a little bit more robust, easier to tune if it's necessary to tune it, and it's hard to make a catastrophic mistake with it. With top K, you could make a catastrophic mistake where if K is too small, like the actual words that you need, maybe you're not fitting in there. Top P, though, is a little bit more robust. Top P invented in 2020, specifically in the context of large language models. Top K has existed forever. It's also known by nucleus sampling. This was the original name for it when it was first created, but everybody nowadays calls it top P. If you look at the documentation of OpenAI or Grok or any of these systems, and you see a P anywhere, they're doing top P or nucleus sampling. The idea of top P sampling is very similar to the top K sampling, except instead of specifying like a fixed number of words, you specify like a percentage of probability mass that you want to sample from. So if our percentage was 10%, then 10% in this particular case right here, we have 4 plus 3 plus 3. These first 3 words here add up to about 10%. And so in this particular case, top P with P equals 10% is equivalent to top K with K equals 3. But top P the number of words that we're selecting from can expand or shrink dynamically depending on the actual distribution over here. And so it's people have found that it tends to work better with large language models, tends to be more effective. And so people these days will tend to use top P instead of top K. By default, OpenAI or Grok, most systems disable it. If you set this to 1, then that's disabled because all of these things, if you add up all possible probabilities over here of all the different tokens, all the different words, that adds up to 1. So that means you're sampling from everything. If you do set this, a value of like 0.5 is a typical value where you're discarding half the most infrequent part of the probability distribution. On the Grok console playground right here, so we showed you before that it has this temperature setting you can set directly right here under the advanced tab right here. Under the advanced tab, you can play around with different values of P, only between 0 and 1 makes sense. I guess, again, going to 0 or top k equals 1, that reduces to the greedy sampling. You're always taking the best. But you notice that they don't even mention top k up here because nobody uses top k anymore. Everybody uses top p with this nucleus sampling. So maybe one last intuition-y thing about the top P, if you're noticing that your model, for whatever your prompt is, whatever model you're using is getting you like really weird words somehow that seem totally out of the blue, that's the situation where I would think about using top P sampling here, and starting with a value of 0.5, maybe going to a value of 0.1 if 0.5 doesn't work. But those are the values that I would test. That's a pretty quick overview of all those different concepts related to top sampling. But any questions about any of that? For your RAG News assignment, this is a situation where you're trying to predict, say, just exactly between two words, either Trump or Harris, or I guess it's like 10 words, including the minor candidates. This is a situation where I would think top K or top P sampling might be particularly helpful, or greedy sampling, greedy search might be particularly helpful. Eliminating as much randomness as possible, focusing in just those high probability words. So I would guess that you could increase your performance by maybe 5-ish to 10-ish% with a good set of sampling hyperparameters here, trying out these different values of things. Sorry, Alex, I cut you off. Had a question?
Yeah, you showed us last time about getting the funnel since give out. So is that mixing with this kind of answers that, or do we keep those separate?
Yeah, so the question is, last time, well, there was a lot of different tricks that we talked about last time in terms of getting our evaluation system to work and give us good performance. In particular, one of those was actually specifying, like, here are the 10 possible labels, or 10 possible classes, or 10 possible words that you should output. And the question is, does it make sense to mix and match both of these things, both of these techniques, or to only use one of them? And I think it makes sense to use both. It's the sort of thing that's like you just have to try different combinations and see what works, see what gives you those best results, those highest numbers. My guess is the right combination of adjusting these sampling things and providing those labels will give you the best numbers. But in general, like all the different techniques that we talked about for improving that performance and any other techniques that exist can all be mixed and matched, and they're not like, it's very rare to find things that are like mutually exclusive with each other. It's a good question.
How do people who like know what you're doing, this kind of stuff, like pick which ones of these techniques to use, like how to balance them? They don't round it until we get good results, and it's like improvement.
Yeah, it's a good question about like how do say an engineer at Facebook who's implementing something with this like systematically do these things. The real answer is that everybody just has like some set of tools that they have stumbled into that's worked for their particular problems, and they just try those particular tools and see if they work. There are ways that you can sort of like automate, like, okay, here there's maybe like 3 different possible K values here, 2 different possible P values, 3 different possible values of temperature right here. We could come up with like sometimes called grid search. If you try all of those different possible combinations together, that is a thing that people do, but it's more just like I have a sense from my past experience that top P sampling is going to be good in this situation. And usually for like most of these things, there's some like intuition or thing you should keep in mind about when it's good and bad. The top K or top P sampling, the the situation where I might think, oh, this is the thing I should turn to, is if I'm getting some like samples that are obviously bad. So like in our RAG situation where we're trying to just predict like, is it Trump or Harris? And I get a word like Democrat, that's like a Democrat is related to the problem somehow, but it's not like one of the things that I really want about it. It seems like if it's picking that word, it's going down a different like track, and adjusting the top P sampling can get rid of some of those like obviously bad samples where it's just going down the wrong path. And then, yeah, like in terms of concrete numbers for things, people just have, oh, I tried 0.5 3 months ago on my other problem, and that seemed to work. So let's try it again, because why not? So that's the answer. Maybe not satisfying, but that's the answer. People just try different things. A good question. Oh, yes. Good question about like where to actually implement these. Let's see. In order to talk about that, I'm going to switch to some code. We'll do a little bit of code here that's going to prepare us for doing this OpenAI stuff that I want to do here in a little bit. And we needed to do this anyways to see what the new stuff, like the power that it gives us. So I'm going to switch my terminal over here to, or switch my screen to these two terminals over here. And in the bottom, I'm going to create, I'm in my RAG news folder right here. In the bottom, I'm just going to create a new file. I think I did inclass.py before. I'll do that again. I'm in a different branch right now. You can call your file whatever you want. And I'm going to just walk through real quick how to use the OpenAI API, which is exactly the same as Grok's. So it's not going to be anything new. But then after I type out our message, we'll see like how exactly to pass these things to the API. The only thing different about OpenAI from Grok is at the top here, I need a from OpenAI import, spelled correctly, OpenAI, and client equals OpenAI. And then the response equals the client.chat.completions.create. I decided that I would type all these things out instead of copying and pasting them from somewhere else, because that way, if you were trying to follow along, you'd have a fighting chance of following me copying these things out. The messages, so the role here of system, and then the, let's format that a little bit nicer. The content of you are an expert on politics. Answer the user question in one sentence. Maybe two. I'll say that if you don't have your OpenAI key set up, that's totally okay. Everything that I'm doing right now, you can follow along exactly with Grok. The reason the Grok API is structured the way it is with this big long function call should look familiar to you. The reason it's structured the way it is because they want it to be 100% drop-in compatible with OpenAI. And the only thing different if you're using Grok is these first two lines up here that import Grok. So there's the messages, and then another role right here of user spelled correctly, and content. Let's do who are the current presidential candidates. So something like we were kind of doing with our RAG news stuff. And then, yeah, let's stop the function call right there. So this is, so we don't have any typos, just everything that we've seen before, how we were calling our OpenAI or our Grok models, passing in this conversation to, for Grok, it's, I guess, you have to specify the Llama, one of the Llama models. OpenAI, I'm using GPT-4 right here. And then we're going to go ahead and run this. In the top window up here, also in my same RAG news folder, I can open this file, python3-i, move that thing out of the way. Python 3-i of, I call it in-class.py. The -i right here again means I'm going to go into interactive mode in Python. And I know I'm in Python because I have the 3 greater than arrows right here. And I created this variable response right here, which contains the details of the actual, like what OpenAI got back. The important things in here, the response.choices of 0 gives me the actual, like the text that they completed in this choice object. And then we want to extract this message content, up arrow dot message dot content like this. And so this is how we got that text back. So everything right here is so far exactly the same. Maybe the first thing that I just want to highlight for us, though, that's important to observe is that GPT-4, like the OpenAI's most recent model that you can use with its most recent training data, this model still does not know that Harris has replaced Biden as the Democratic nominee. And something like RAG is required even if you're using OpenAI or Anthropic or Google Gemini. No matter what models you're using, RAG is often needed to add new information. Ethan.
If the model were to run out of 4.0 usage, would it just automatically go to?
It's a good question about like OpenAI has various different quotas that you have to observe. In general, every of these systems have different quotas, and it's very rare for systems in any situation, LLM world in particular, or other situations as well. It's very rare for systems to automatically degrade you. Instead, if for whatever reason I was not allowed to use GPT-4 right now, then I would get a message about you're not allowed to use that, hopefully telling me why, but then it would be up to me to reselect a new model right here that I was allowed to use. Very basically non-existent, where systems will try to fix errors for you automatically. On the top window?
Yeah. Is your API here?
This thing right here is not my API key. Good catch though, trying to look for API keys. This is, so every chat that you do on whether it's OpenAI or Grok or any of these systems, they index all of those chats, they store them forever. So that they can, especially in OpenAI's case, they can do future training runs on your data. And this is the index, the ID, the name of this particular chat that we're doing right here. And so if like maybe I find a bug in OpenAI's protocol and I want to tell them about the bug, then I can send them this ID right here and they can look in their database and see exactly what was going on. So it looks like an API key because it has a bunch of random gibberish stuff, but that random gibberish stuff is a very common thing to appear in lots of situations for different purposes that are not APIs. But I like it, looking for API keys. Max.
Are you able to query your past chats with this ID?
Question is, can you query past chats with this ID? And the answer is that I don't know how to, but I'm sure that there's an API call for doing that. It's the sort of thing that they want people to do. Ethan.
How come in this response log, it says that the role is assistant, and you specify in the system content that you should be an external call?
Yeah, it's a good question. Over here it says role is assistant. Over here I have role system, role user. This role equals assistant means that like the very next thing that happens, the thing that ChatGPT is giving to me right now, is the next thing that happens in the conversation, which would be a role assistant like this, and then here's the contents of whatever it passes out. Turns out there are different roles that the ChatGPT models or the Llama models can do besides assistant. We haven't talked about those, but this could be different if the model decides to adopt a different role besides assistant. In general, I don't think any of these things in here are interesting other than the content text part that we actually output right here. The other stuff, yeah. They have uses in different situations, but not related to anything that we're doing. The original question though here was, okay, if we have this API, how do we actually specify some of these hyperparameters, like the temperature, for example? And the answer is that it is one of these parameters that you can pass to this function right here. So you can do something like temperature equals 0 to set the temperature to be 0. And now we should have a more deterministic model right here. I'll rerun this, run that right there. And so that's our output with temperature 0. I'm going to press Control D, up arrow, rerun this, get a new query, and we'll see if it is exactly the same thing. And it's not exactly the same thing because of weird hardware technicalities that floating points are not deterministic, but it's very, very close to the same thing here. That most of these letters are like, or most of these words, most of these tokens are matching up. It looks like it just had a hiccup. Democrats versus Democratic Party right here. So it's still hard to get like exact deterministic behavior from these things, but the temperature 0 can help get you there. The other parameters are, so it's doing like K equals or P equals to specify the other things. If you look at the documentation of this create function, it'll actually have like 10-ish, maybe 20-ish different things that you can set right there that will slightly modify that how it selects some words. So another thing that you can do, for example, you can say, specify that it's never going to repeat the same word twice in its output, which is not useful for us, but could be useful if you're, I don't know, writing a poem or something and you want it to be, talk about different things. Did that answer your question, Amelia? Going back to, cool. Yeah. Okay. I'm going to come back to GitHub just for a very short second here. Beam search here is the really interesting search strategy. This is the one that's far more interesting than the greedy search or the top sampling. Something that most people, when they hear about large language models, they don't hear about this. None of the like introductory like YouTube things that talk about large language models talk about beam search. But in my view, this is one of the most important things about why large language models are not necessarily stochastic parrots and why they're not just doing necessarily next token prediction. So what this beam search is going to allow us to do, the main advantage of beam search here is that it's going to allow the model to look multiple tokens ahead in the future when it's performing its inference. So when it's deciding what token to look, what token to do next, when it's at this step right here, it says the best thing about AI ability is to do all this thing. In some way, this beam search is going to allow us to predict or to decide which one of these words we should select based on what the future is going to be. So it's if you're using beam search, you're not just doing at inference time, you're not just doing next token prediction, you're somehow predicting like large sequences of phrases. And so that can let you let your model look into the future in some limited sense. Disadvantages, so we'll talk about the details of how that works here in a second. Disadvantages is that it is extremely slow on non-local models. So things like OpenAI and Grok, non-local models, because you have to use the internet. And roughly the reason why this is slow, the way to think about why it's slow, is that you have to make an internet connection for every token, an internet connection for every word in the text. So rather than just a single internet connection to the client and back, you're making many, potentially thousands of internet connections. And each individual one is fast, but that adds up. It's also much more expensive on things like OpenAI, where they charge by the token, because you will be sampling many more tokens than normal. I've told a story to some of you about how OpenAI canceled my account 2-ish years ago from, they thought that I was being abusive. I wanted to pay them a lot of money, $5,000 to do some sampling of things, and they wouldn't let me do it because they thought I was being abusive, because I was doing some beam search stuff, and it was costing a lot of money, and they didn't think that I should be doing that. But so that is a disadvantage of this. You have to be really careful if you're using beam search on these APIs to not accidentally spend more money than you're willing to. Another disadvantage right here is there is no streaming support for these beam search techniques. We haven't been using this streaming support, but this is like when you're using ChatGPT and you see that it's like outputting words at a time on your screen, that's what it means by streaming. And if you're using beam search, because it's kind of looking into the future somehow, it has to like just do it all at once. Pause for questions in a second. One last thing that I want to highlight here is that Grok does not support the use of beam search at all, because Grok is slow or because it's really fast. That's their like key thing, and they are 100% free. They do not support beam search at all, and because if you use beam search, things are going to be slow, and so that takes away the whole advantage of using Grok. And if you use beam search, you're going to rack up a huge bill really quick, and Grok is not charging, so they don't want people doing that. The one way that in Grok that you can use beam search, though, is if you enable JSON mode. You will be using beam search to do this. JSON mode in every API system uses some version of beam search. And you can see here that it also mentions here there's no streaming support with JSON mode because of this beam search idea. Nolan, did you have a question?
Yeah, maybe you can be helped, but I'm just confused on why it's slow for non-local models. What additional information is required from the client?
Yeah, so the question is, why exactly is it slow? We're going to go over here in the detail, like the algorithm here in a second, and so that'll answer that. Ro. I don't think that's my computer, but yes, something is hissing. We have a snake wandering around through here. A python, or the python has escaped. Okay, so let's actually talk a little bit about the beam search details here. We're going to do it super intuitive here, high level. Then we're going to see how to do it in the OpenAI API really quick. And then we're going to see something really cool that builds off of beam search and combines cool programming language stuff. So here, where I'm going, where I just clicked this link right here, Hugging Face, if you haven't heard of it, they're one of the more recent-ish, couple of years ago, big startups. They started just 2 people trying to make downloading models really easy, efficient in code. They didn't like how different overhead things inside of PyTorch and TensorFlow made sharing models really awkward with people. So they started this company just trying to make sharing models really easily, and then they sort of like accidentally raised a couple $2 billion in funding. Most companies like set out to raise a couple $1 billion in funding. Hugging Face is one of the few that was like accidentally people trying to just do something cool, and it turned out to have a good product attached to it. But they have a bunch of these tutorials on their website. So there's a lot of details in here about beam search that we're going to skip over and just focus in on 2 figures here. So this figure here, step 1, shows the first thing that happens in beam search. That if you have like your original sentence that you have so far is just the word the, then when we do a sampling step, the model is going to figure out like what are the next most probable words that come after the word the. And in this case, they just show the top 4 most probable words right here: dog, nice, car, and boat. And those are the 4 most probable words. They don't show the probabilities. They're just saying that these are the 4 most probable words. And if we were doing a sampling strategy or a greedy strategy, we would select just one of these words and then keep going. In beam search, though, we select some number of these words. In this case, they're selecting 3 of these words: dog, nice, and car, and keeping all 3 of these words. The amount of words that you keep on each of these iterations is called the number of beams. And so this is a beam search with the number of beams equal to 3, because we are keeping 3 words over here from this probability distribution right here. So we started with the word the, and then instead of just saying the dog, we're going to consider the dog, the nice, and the car, all 3 of these options. The next step is that from the dog, the nice, the car, whatever our current like database of possibilities is, we're going to sample 3 more beams out of each of those situations. So from the dog right here, we might say the dog and, the dog runs, the dog has, or from the nice, we might say the nice woman, the nice house, the nice guy, and so on. We put all of those in another like big bank of possible words, sort them by the overall probability of the phrase all put together. So the phrase here, like nice woman or the nice woman versus the dog and. And so we can see that the dog and is the most probable thing, the nice woman is the next probable thing, and then the dog runs is after that. So this sorting over here can like arbitrarily mix up the sampling from these different beams over here. And then after we do this sorting, we pick what in this case, we're doing a beam search with 3. We pick 3 of these samples right here, and that is our current output. We'll repeat that step again, sampling more times for each one of these 3 things, and doing this sort of what they have illustrated here in step 2, over and over and over again, building lots of different sentences down here with lots of different possibilities about what might happen. And so here, like between the reason why I said beam search somehow allows you to see in the future, whether we pick nice or dog as our second word right here will depend on whether we pick and or woman as the third word right here. In this case, we're definitely not picking the word car because we either are picking and woman and runs as our third word right here, and car is not related to any of those third words down here. There's a lot of different like philosophical interpretations of beam search about what's going on. This article, if you want to read it, talks about some of those things, but this is the basic iteration, is that at each step you're keeping track of many different things, many different beams, many different possibilities of the future, and sampling from all of those. The reason, so back to Nolan's original question, why is this slower? Why is this more expensive? So it's more expensive because you have to do a lot of sampling from your large language model that the user is never going to see. At each one of these iterations, we're doing taking a bunch of samples and throwing them away. And so that makes things more expensive. The reason why this is slower is because this is not something that is natively implemented, say, on the end of the OpenAI API or the Grok API. It's not happening inside of their servers. If you're going to do something like this, it's going to happen on your end, at least once you start doing any of the interesting things here. This basic setup can happen inside of OpenAI's system, and it won't be slower if you're doing it in just their system. But once you do the interesting things, which we will get to here in a second, that's going to happen with lots of rounds of communication. Sort of the logic of when you take what you keep and what you stays happens on your computer, and the sample of each word happens on OpenAI. And so you have to do a lot of communication back and forth because of that.
So is the feature that OpenAI supports that Grok is not log prop?
So the question is, yeah, why exactly does Grok not support this? What have they disabled? And there's a link to this page over here. But yeah, in order to be able to do this, you actually have to get the exact probability of each word. And Grok has specifically disabled that. Their hardware supports that, but they have specifically disabled that because they don't want people doing beam search because it does not make their system look good, because beam search is slow and they're trying to advocate for fastness. It turns out that, like again, the really good state-of-the-art systems, beam search is, unless you're doing something really cool, not something that you need to worry about. 2 or 3 years ago, beam search, kind of like temperature, was something that you could fiddle around with and get much, much better performance. Now performance is good enough kind of by default that the beam search is less important unless you're doing something really cool. And I keep saying something really cool, so I want to get to something really cool before class ends. So we're going to jump straight there. Bunch more notes here. Yeah, I guess maybe one thing about LLM world sampling versus traditional sampling. So in the department, Professor Cannon, Professor Huber, both do work in like traditional sampling fields. They care that their things converge to actual like real distributions and write proofs about those distributions. All of these algorithms can work in those different situations, but the large language model people don't care about any of that stuff. Okay, so on to coolish stuff. Things that I think are boring here, library-wise, these 3 libraries, people have asked me about them, different things. Why do I think they're boring? They basically re-implement the stuff we did in the RAG situation, but with a bunch of wrapper stuff around it, which just makes it harder for me to understand what's going on. If somebody were using these systems, say in like a final project in this class, which we'll probably talk about next week, details of that. But if you wanted to use one of these systems, that would be fine with me. I just don't personally find them interesting. They don't allow you to do anything that we haven't done with the RAG system. They just, in my view, kind of get in the way, because then you have to know what's going on under the hood, and you have to know what the library is doing to make it happen. But the thing that I think is actually cool, and that's going to allow us to do this cool stuff with theme search, is this thing called the Language Model Query Language, LMQL. It's billed as like SQL for LLMs, and so everybody knows in the data science world, SQL is super important. So if you're telling people that you're using like the SQL for LLMs in like a job interview or something, I think people will find that to be a really cool thing. Most people in the machine learning world do not know about this library. They're much more familiar with these libraries because these libraries come out of machine learning people. This library down here comes from the programming languages community. PLDI is the Programming Languages Development something conference. And so it's a programming language person who invented this. Programming language people are stereotypically like doing cool stuff that nobody else in the world cares about for 20 years. And then in 20 years, people think, oh yeah, we should have been doing this all along. One of the standard examples of this is in Python. List comprehensions they were invented about 20 years before Python, used in functional programming. Once Python developed or added them to the language, then everybody realized list comprehensions are a really cool thing. But Python did not invent them. They existed in the programming language world for about 20 years before Python, but everybody these days thinks that Python invented them. My prediction about the future is that something like the large language model query language will suffer a similar fate, that because it came out of the programming language world instead of the machine learning world, nobody will care about it for a long time. And then at some point, a machine learning person will say that this is mine, and then everybody will think it is super amazing. Okay, let's actually do some stuff with it. So this library is dependent on this interface that Grok disabled, and so it is not something that you can do in Grok, and this is the actual thing that you need the OpenAI key for. This is all stuff here that we'll probably get to the part where this could really help in your RAG system. We'll probably get to that today. And so if you would like to do this, you're welcome to incorporate this into your system, but you are not required to do that. Again, you have to be very careful when doing this because you could easily rack up a large bill on things. Maybe one thing too that I'll say here is that all the documentation for OpenAI, they always have their most expensive model as the default model to use. So never use this as like your default model when you're trying things out, that you will rack up a large bill this way. And instead, we'll use an older model, GPT 3.5, while we're experimenting around with things. Let's see, the actual library here. So pip3 install LMQL. If you do that, you'll get access to the library. The way you use it, import LMQL, something like this. And then it's kind of like what we were doing in SQL, where you write some sort of query variable like this, and then you call that query, pass it to the large language model. And that call looks, the syntax for that is lmql.run synchronous, run sync of query, and we'll put that in a variable x like that. We're going to put in a query here after we see the syntax of what LMQL looks like, and then we'll check out the result here in this X variable. Maybe we'll be a little bit nicer and say this is the result right here. The syntax for this query is a little bit, there's some awkwardness because of the Python integration here, but I'll just write out an example, and then we'll see what's going on. The system, the query that I'm going to try to simulate is something like this query up here, but then we'll start doing some interesting stuff with beam search related to this query up here. So I'm going to copy that first system prompt right there, paste it right there, and then I'm going to copy who are the current presidential candidates right here, and paste that right here. And I'm going to put this as AQ, and then I'm going to put, no, that's the question and answer. And right here, I'm going to say answer like that. And awkward-ish thing is that you have to explicitly put \ins over here. The syntax of what's going on here is that all of this stuff right here, anything that's inside quotation marks, is something that is going to be passed directly to the large language model. The stuff that is inside square brackets right here is the stuff that the large language model is going to spit back to us, and we can do like provide interesting constraints on what it is that it spits back. To see that, I have to specify a sampling algorithm that we're going to use. The argmax is the simplest of those. Argmax is the same as greedy search. We can change that around in a little bit. And then I have to specify like the actual model that I'm sampling from. I'm going to sample from OpenAI/GPT-3.5-Turbo Instruct. Is there, at least from what I have access to right now, the cheapest model that they have. And then a where clause. Well, we'll start without the where clause and just see what happens. So this is going to be the exact same query that I had up above, only going to GPT 3.5 instead of GPT 4. I'm going to up here, let's rerun this code, going into Python. I have this unterminated string literal. One of the awkward things about this is so this is a syntax error inside of the LMQL code, which is right here. Let's see if that's, I'm going to fiddle around with this, trying to fix that syntax error real quick. I think the R right there did fix that. The R in Python, again, is a raw string. It means this \n is not interpreted as a new line character, but is just a literal \n. So it will pass \n into the quotation mark right here. And my get result right there, result here is the answer right here. If I do result.variables, variables is going to be the dictionary of all the things that I have in square brackets that the model is going to try to figure out for us. And in this case right here, it says that the answer, the current presidential candidates are Joe Biden and Donald Trump. So we see that the model still does not know like anything about the current state of the world. But I'm going to do a weird thing next, adding a constraint to this, which is going to let the model know something about the state of the world in a way that is going to be, we will see, simpler than the RAG system and just as effective. So down here, again, my argmax, this is the thing that like somehow defines my distribution up here. This is the thing that I am asking the model to provide for me the answer to what my question was. But now here, kind of like in SQL, where there's a where clause where we can provide constraints on what the output is, in LMQL, you can also provide a where clause and provide constraints. And in this case, the constraint that I'm going to provide is where answer is in the set of Trump, comma, Harris, like this. So now I'm forcing the model to do two things. First thing that I'm forcing it to do is output only a single word. So it's not going to output an entire sentence like this. It's going to output just a single word, which is either the word Trump or the word Harris. The second thing is that notice that Biden is not one of these answers. Harris is the answer here. And so now the model is only allowed to output one of these words. And actually, before I do that, got one step ahead of myself here. Let's comment these out. I want to change this. Who are the current presidential candidates to who is the current Democratic presidential candidate. So same basic idea. I just want to see that this is still going to give us a sentence that does not contain the word Harris, but could be answered in one sentence. So I guess it does contain the word Harris, but it's still talking about Biden here as being the candidate. But down here, if I add this constraint where the output is either Trump or Harris, then the answer can no longer be Biden as the president, and the model has to decide just between the word Trump and just between the word Harris. And because it sees like Democratic presidential candidate, it makes a pretty reasonable guess that Trump has not become the Democratic presidential candidate, but that Harris is more likely to have done that. So the interesting thing here is just that you can add this sort of constraint. There's a big syntax of what those constraints can possibly be, but some sort of constraint on how this sampling algorithm is doing things, and that constraint can force the model to acquire some additional piece of knowledge somehow, or force the model to output in a nice way. I'll pause here for a second, but first, the way this could be used inside of your RAG system, the evaluation system, is that if you had an actual constraint that the answer has to be Trump or Harris, then that will greatly improve your model performance. Previously, what we did was we added to the prompt something like possible options are Trump and Harris, something like that is what we did. This suggests that these are the things that could be the outputs, but it doesn't force the model to make those things be outputs. And so occasionally we got weird things where the model would actually provide a sentence, for example, saying the candidate is Harris, or the model might try to say something instead of just like the word Harris, it might try to say Kamala Harris or something like that. But by adding a constraint like this, you can force the model to actually only pick one of those two things, and that'll, in a similar way to how adjusting the top P system can make your model focus only on the better quality answers. This can do an even better job of making the model focus on only the better possible answers. If you were to do something like this, I would expect you could get a lot of performance boost by using a more state-of-the-art model like this. Change that to GPT-4. But this also adding a lot of performance boost, and this being the main thing that adds performance boost. I saw Ainsley's hand up a second ago.
What version of
Question is, what version of LMQL am I using? And I am using whatever the most recent one is, whatever got installed when I did pip3 install LMQL. Pip3 freeze pipe grep LMQL 0.7.3. I originally did this on Python 3.9, and it downloaded an older version because the newer versions do not support older Python versions. So I used my PyEnd, which we sort of talked about at one point, to upgrade my Python version and do this all in 3.12 instead of my default installation. Nolan first.
Is there a reason you're using Turbo Instruct?
Question is, why am I using Turbo Instruct? And for me, it was just this was the cheapest one.
So you can also use chat models?
Yeah, so any model that supports that OpenAI has is something that you can do right here. There are certain models that have different features allowed versus not allowed, which change what's allowable in the constraints down here. But any OpenAI model is allowed to be right here. You're also allowed to use you can do any local model, like, so on Grok, we were using the Llama 3.1 models. If you had that hosted somewhere besides Grok that supported the log props, the models themselves support that. It's just Grok interface doesn't. You could do that here as well. So it's basically anything can be put right here. Abizer?
So the difference between what you're doing now and what you were doing before is that the argmax is adding top the sampling?
Question is, what's different between what we're doing now and what we're doing before? Is it related to the argmax? The answer is no. The answer is this constraint right here. I'm adding a where clause right here that forces the model to, like, when it comes to this spot and it's deciding what the next word is going to be, it can only pick between these two things. This is similar to like what top K is doing, in that top K provides some way of constraining what the model picks from, but what the model picks from in top K or top P are like not domain specific things. It's just like from the probabilities. This is allowing you to add actual domain specific knowledge in here. Let's see, I want to do one more example to give the extent here, get you more of a sense of like the power of these sorts of systems. And so what the thing I'm going to illustrate right here is why we need quotation marks right here, why we have this so again, quotation marks are things that are being passed directly to the language model. Anything that you have outside of quotation marks, but that is indented inside of argmax, is valid Python code. And you can include a vast majority of possible Python code here. So I'm going to change this question to what are the main issues in the current election? And I'm going to create a variable right here called issues. It's just traditional, and when you're using query languages like SQL or this to make your variables in uppercase, but it's not required. And then I'm going to do for I in range 10 dash issue, adding a constraint on this particular line right here where stops at issue comma \n. This stops at constraint says that the model is going to output a bunch of stuff here, and when it outputs a \n, so when it outputs a new line, that is going to be the end of this issue variable, and then we're going to keep going on. And I'm going to do issues.append of issue. Whatever the model put inside of here will be put inside of this issue variable right here, which we will append onto this list right here. And then we can do a return of that issues variable like this. So details of the syntax, maybe not super important, but just getting a sense that this is something that like is a complicated thing that you can add lots of like weird constraints to. And here, what like the intuition, but what I'm trying to get here is that I want a list of an actual Python list of what are the issues in the current election. And I'm going to do that by having the model output one issue at a time. The dash up here up front's like a markdown sort of formatting. And then that issue is going to be everything between the dash and the new line that comes next. I will, let's see, that's, there's no answer now, so no constraint right there. I have a constraint up here, and rerun this. Hopefully there's no syntax errors. Notice that it's taking a long time to run now. This is, again, that issue where there's a lot of network connections going on back and forth between the LMQL library and OpenAI, but it didn't get me any errors. If I type result right here, then I get this list of things. This is not a very good list right here, that everything just happened to be put in the very first entry right here. I think I can fix that really quick by changing this argmax to, let's do a, make it actually sample something, temperature equals 0.8. See if I can fix that really quick. Again, if I kind of usually to start with like a greedy sampling approach, and then if I get something that is like not following my pattern enough, or it's like too, doing something too rote, then add a little bit of randomness here. And let's see if that sort of fixes things. It's still giving me a bunch of long stuff right here. So, Well, yeah, there's some debugging to go on here. How have some things slightly different between what I wrote here and what I wrote last night playing around with this. So it's not giving me just like a literal list of like the economy, healthcare, immigration. But hopefully this gives you a sense about like the power of something like this, that you can write very complicated queries and have them force them to be in certain formats, and getting those results out in a convenient to use Python form with a tool like this. Not required to use this on your homework assignment again, but if you choose to do it, you will get a lot of performance boost just from being able to provide these constraints.
It would be good to say answer basic question.
Here it is. Related to that, I don't actually, what I need to do, what are the main issues for the current election? The main issues are in the following list. I need to tell it that I am providing a list right here. And so now it'll answer as one sentence, where that sentence is broken up with a bunch of dashes down here. Apologize, I have gone over time, but so here you can see the first issue is COVID-19 response in healthcare, then economy and job growth, racial justice, police reform, and so on. And so we can get a list of different things that way. I could add more constraints, getting this to be just like one word on each thing if I wanted, by adding more constraints right here. But we're at a past time again, so it's a good stopping point. I apologize for going past time. If anybody has questions about this or the homework assignment or anything else, I will stick around and get those questions answered. Otherwise, good luck on the homework assignments. Please do the reading. Please be on time. And on Wednesday and present, probably will not be able to record what we're going to do on Monday next week. You're welcome.